Okay, this is 5.2, multiply polynomials using FOIL. So we're going to use FOIL here. I did mention now you've seen 3 different methods to multiply polynomials. You've seen FOIL, you've seen the grid method that we covered yesterday, where we draw a squared grid, and then on the left and the top you draw your terms, and then you just cross multiply. So that's one way. We've seen this way, and now we saw Khan in the video in the content section cover a 3rd way, okay, which is adding a sort of intermediate step. To multiply 2 polynomials, you're going to use the distributive property. Remember, the distributive property is where we multiply one term we distribute it into both terms within inside a bracket. But we're just doing that now with 2 terms multiplied by 2 terms. Okay, so this is the this is the method that Khan was suggesting. So he takes 5x and he multiplies it by 3x minus 2 here, and then he's multiplying 1 times 3x minus 2. So he was suggesting that you add this step in without using FOIL. Okay, and now once we have this, we can use the distributive property with just the 1 term multiplied to the 2 terms, right? So you get 5x times 3x is 15, x squared minus 10x plus 3x minus 2. Okay, and so what we find out then is this is the product of the first terms, this is the product of the outer terms, and this is the product of the inner terms, and this is the product of the last terms. So that's how we get FOIL. Okay, so there is the following are the steps in FOIL method. Multiply the first terms, the outer terms, the inner terms, and the last terms. So they don't call it the outside terms, they call it the outer terms, whatever, same thing. Here we go. Use FOIL to rule, the FOIL rule to find each polynomial byproduct. Okay, so we're going to do 4d times d. We get 4d squared. That's the first terms. Okay, then we're going to do the inside terms. So minus 2 times d is minus d. Then we're going to do the outside terms. So we do plus 4d because it's 4d times 1. And then we do the last terms, minus 2. And then usually, well, always pretty much, when you have your variables set up like this, where you have the same variable in the front and no variable in the end, it's always the middle 2 that you need to combine. So we're going to do that now, and we'll just get plus 2d minus 2. Any questions? No questions. You're all good? Everyone's comfortable with this, right? Can I go a bit quicker? To give you some time? Good. Okay, so we're going to do 3x times x, 3x squared, 3x, the inside terms. Actually, I just realized I don't do it that way. Sorry? Oh, you can't see? What? Sorry? No, I was just realizing this. This is the way I do it, actually. I'm forcing myself to use FOIL, but the way I do it is I go 3x times x, 3x times 3, so I'll do plus 9x, and then I'll do minus 4x minus 12. You guys see that? So I'm doing the first term times both terms, second term times both terms. So I'm not actually doing FOIL. Is it FOIL? What'd you say, AJ? Yeah, that's first. So what I'm actually doing is I'm doing first, and then I'm doing outer. No, first, outer. Yeah, inside. Oh, I am doing FOIL. Never mind. Yeah, I'm doing this, 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 this. Yeah, it is FOIL. It's the same thing. Okay, so now we get 3x squared plus 5x minus 12. Okay, so yeah, I just don't think of FOIL when I'm doing it. It just takes too long. I'm just like 2p times this and this, 5 times this and this. That's what I'm doing in my head. I'm not going FOIL. I'm just going first one times 2, second one times 2. That's what I'm doing. Okay, so I get 6p squared minus 4p minus 15p plus 10 equals 6p squared minus 19p plus 10. Any questions so far? Yeah. Ask what?
I was going to ask you.
Yeah, go.
3a cubed
Yep.
plus 9a squared negative 4a negative
Beauty. Keep going.
So that's it because you can't.
Sorry?
Yeah,
Sorry.
you can't go past that.
Oh, you're right. Sorry, I thought I made a mistake. You were right. Sorry. You can't go past that because there's nothing common, right? 3a squared, 9a cubed, minus 4a, minus 12. Yeah, good. And always try to get in the habit of doing this, guys. I know, again, you're not writing necessarily a lot of tests here, but you will. Likely next year. Expand and simplify. Okay, so now we have something else going on. So we don't just have our regular thing happening. We have a 2 that's been introduced. Yeah, maybe? You want to get? Let me just explain it first. So one, you can do this two ways. You can put the 2 into the first bracket only. So you can do it. Here, I'm going to show you 2 ways to do this. Okay, you can either do it like this. Okay, I've combined that 2 and the x minus 7. It's not going to both. It's just going with the first one. Okay, and now I can do my regular FOIL here. So I'm going to get 4x squared plus 2x minus 28x minus 14. Okay, you can do it that way, or you can leave the 2 on the outside and multiply, do your binomial multiplication first. So you're going to get okay, you get your product of this first with the 2 on the outside, and now the 2 will multiply. So you can, well, let's simplify that bracket first. And now we can multiply the 2 into it. So see how we got the same answer? Same number of steps, looks like. No, actually, one extra step here, because I didn't have to do this step. Right? I could have just looked up. Oh no, I did. Never mind. Same number of steps. Any questions with this one?
Sure.
Yeah.
If you put the 2 into the x and the minus 7, wouldn't it take out the brackets?
No,
Oh,
it wouldn't. If you took out the brackets, then you would only have the 7 multiplying by to this. And that would be wrong. Okay? You can't do that. All right, this one, B. So now our negative sign, what you're going to do with this one is, my advice, leave the negative outside. Deal with all of the inside first. Okay, so you get x squared minus x minus 4x plus 4 plus, I'm going to do the same thing. I'm going to leave the 5 on the outside so I have smaller numbers. Deal with the inside. So I'm going to get 6x squared plus 3x minus 2x minus 1. Now I can distribute that negative sign.
So, sir, how did you like put them together? How did you like combine them?
Which one?
Like for the both?
I did FOIL.
Oh,
Right? This is what we've been learning, how to combine these two, right?
yeah.
You're doing this times this, this times this, this times this, this times this. Okay? So now the negative sign goes in, and I can get rid of the brackets. And now this 5 is going to go in, and I'll get rid of those brackets. It is getting heavy over here. Look how much is going on here. Okay, now minus x squared plus 30x squared. Those are my two. 29x squared right? And then I combine my x's. We got 4x plus x is 5x, plus 15x is 25x, minus 10x is plus 10x. And then I have minus 4 and minus 5. It's minus 9. All right. Here's my final. Yep. Yeah, go. This is a square, by the way, because it was a mistake. Okay. Go ahead, Jadine.
3x
Yep.
times x squared.
Mm-hmm. So what is that?
3x cubed.
Yep.
And then you do -4.
Nope. You can do 3x times all three of these terms first. Yeah, so negative 5x is what? Yeah, negative 15x what? X times x? Yeah. Okay, now the last 3x times 2. Yeah, good. So now the 3's are all done. Now let's start with the 4's. So you have negative 4 times x squared. Right? And then negative 5x equals, not negative. Negative times a negative is, okay, positive 20x, and then negative 4 times plus 2. Good. Okay, now we have to gather like terms. So I look for the highest terms. I have 3, so there's nobody else as high as that, so he goes by himself. Now I look for the squares. Negative 15 and negative 14 gives me negative 19, x squared. And now I have 6 and 20, so I get plus 26x. And then finally I have minus 8. Questions with that one? So notice that one, there was 3 terms here. We didn't even really talk about FOIL at all. I just used that same technique, right? Take the first term, multiply it by all the terms in the second one. Second term, multiply it by all the terms in the second one. Okay? Next. We're going to do, I'll do this one quickly. 4x. The 2's on the opposite side, but that's okay. 4x minus 6. And then this negative sign gets distributed to both. I've been yelling at you guys about that for 2 days. 4x minus 4x is 0. Negative 6 minus 9 is negative 15. I think this actually, sorry guys, I think this was supposed to be a square as well. So we'll put it up there because I need to show you that. When something is squared, that means that it's multiplied by itself. Yeah. You see that? What I did? I just rewrote it twice. Now we can use distributive property. Minus 12x, minus 4, minus 16x, and then the 9's go away. That's it. Good? All right. Example 4. Write and simplify an expression to represent the area of the shaded region. So, the shaded region is this, the dark region. So how could we find that area? Who knows? I don't know what to do before we can do it, did you?
Like Find the area of the shaded square and then minus the area of the white square.
Right, so find the area not of the shaded, but of the whole thing, which includes both, and then minus the area of the small one, right? So how do I get the area of a square or a rectangle? Yeah, length times width. So we're going to call this the length, we're going to call this the width. So what we will do here to find the area of the whole thing, the area, and I'm just going to write whole, is going to be equal to x plus 6 times x minus 3. Okay? So we'll do that, x squared. Now one quick way if you can do this is how a little more advanced, is I hate having that extra step where I gotta combine the like terms. And you always know when the like terms are coming, right? There's no surprise, right? It's always those two middle terms. So if you're good enough, if you're quick enough, if you're sharp enough, you can carry one in your head. Okay, so let's try it. So I don't advise this if you're not finding this easy, but if you are finding it easy, you can do this in one step, right? You just do x squared. Now I have negative 3x and positive 6x. So I know that's just positive 3x. And then minus 18, and I'm done. Beautiful, eh? You're just carrying that one number. Now, comes with some risks, right? If you mess it up in your head, you're going to screw up. So if you want that extra step, you can. But that's personally what I do. I can carry one number in my head, and then it's the very next multiplication. So you're not carrying it for a long time, right? You're going 6x, right? And then you're going negative 3x. So you just combine them, boom, 3x. Okay, that's the area of the whole. So the area of the white portion now, right, this blank white area is going to be x plus 1 times 2x. Okay, so I distribute the 2 to each one of these. I get 2x squared plus 2x. All right, so now the shaded area of the shaded is equal to the area of the whole minus the area of the white is equal to x squared plus 3x minus 18 minus, and I have to put this all in brackets, otherwise I would have messed up, 2x squared plus 2x. You guys see that? Had to put that in brackets. If I didn't put that in brackets, then I would have distributed the negative only to the first term. But you want to subtract the whole area, not just part of the area. So that negative has to go to both terms. It's the only thing I got to deal with in brackets, as BEDMAS tells us. So I'm going to leave everything else the same until I distribute that negative sign. Now that I've done that, now I can gather like terms. So x squared and negative x squared is negative x squared. 3x and negative 2x becomes plus x, and then negative 18. So that is our area. Yep.
Why didn't we make it just one whole equation?
One whole. You could. You could have, if you like right from the beginning.
Yeah.
Could have. It's not as like kind of neat. You just started writing shit, and it's not going to be like clear. If you make a mistake, I can't give you part marks. You know what I mean? Yeah.
Isn't negative x squared the same as x squared?
No. Negative x squared the same as x squared. No. This would be the same as x squared, but negative x squared, with the negative is outside, the x value gets squared and then it gets a negative sign.
Okay.
Okay? Because that square does not belong to that negative sign. He's outside of the x, unless it's in brackets like this. And then I know what you're saying. It's still going to be a positive value. Then if you include imaginary numbers, which you will in university, it gets all kind of crazy. So they're definitely not the same. But don't worry about that. All right, 5. A rectangular prism has a width of x centimeters. Its length is 4 centimeters more than its width, and its height is 5 centimeters more than its width. Draw a diagram of the prism. Okay, you guys know what a prism is? A rectangular prism? It is this. You can show it on the camera. Zoom out. This is a rectangular prism. Okay? It's like a square sphere, right? It's a prism. It's a 3D object that is rectangular. This is a rectangular prism right here. Okay? So we're going to draw a diagram of the prism. So I'm just going to do my best effort here and draw a 3D prism. Okay, there it is. It looks more like a cube. I'll extend the length a little bit so it looks more like a rectangular prism, not a square prism. Square prism would be a cube. Okay, there we go. There's my prism. All right. So it has a width of x centimeters and its length is 4 centimeters more than its width. So who can help me label this? If this is my width, let's call this, and this is my length, who can help me label this? Yeah, it's no, its width is x, right? It says width is x. So width here, this is going to be x down here. Okay?
Length is x plus 4.
Yeah, good. So we have x plus 4 on the length. Yeah.
The height.
And the height. Oh, shoot. This is height. So x plus 4, we'll put the length down here. And this is height. The way I have it drawn is 5 more than its width. X plus 5. Okay? That's what we should have. Any questions on how Ethan came up with that? Now we're going to write a simplified expression for the volume of the prism. Now this is from grade, I want to say grade 6 or 7, where you're getting volume of a prism. Does anyone know what the formula is? The volume of a prism. It's going to hurt you guys in this course. If you don't know your basic geometry, you're going to have a lot hard trouble answering these questions. Lucas? Yeah, length times width times height. You have to know that. I'm not teaching you that. This is prior knowledge. Length times width times height. So then we know we can take our length, which is x plus 4, our width, which is x, and our height, which is x plus 5.
Does it matter which way you order it?
It does not. But that's a weird way to order it, so I'm going to just rewrite it like this. Okay? Now, what we can do is we can either multiply the x in, or you leave it on the outside and deal with the polynomial multiplication first. Okay, so I kind of like to leave it on the outside, I think. So I get x squared. So now I'm going to do this carry, right? I got 5x and 4x. So I'm just going to do plus 9x plus 20. Nice, one step. Now I just put the x in. That's our volume. Any questions? Okay, C. You're going to write a simplified expression for the surface area of the prism. Wah, wah, wah. Who knows surface area of a prism? Surface area of a prism.
What does that mean?
Surface area, it means like this area, this area. You know, like area of a square, right? So surface area of a prism just means all of the squares on the prism. Add it up. So I'll tell you right now, there's going to be a bunch of plus signs in this formula. Because you're taking this area, plus this area, plus this area, plus this area, plus this area. Nice thing about a prism, though, is that these areas, what do we know about them? They're the same. So you're going to, I'll tell you, the formula is going to involve a bunch of pluses and 2. There's going to be 2 somewhere. right? Yeah, AJ?
We do x plus 5 times x.
Yeah, let's do it before we're using the actual values. Let's just get the formula though. Anybody know what it is?
Base times height.
Something like that. Base times height, yeah? What is it? Yeah, Lucas, you know?
Is it base times height divided by
Base times height divided by 2? No. No, you're talking about, I think, a triangle? Yeah?
Would be like 2
Yes, it would be 2 bracket. Yes, something. Yep. What?
length.
Yes, yes, yes. Length.
Width.
Yes, you're getting it. Length times width, right? Plus, he's deriving the formula in his head. This guy's like a math savant. But that's what it is, right? We're just adding these areas up, right? So if this is the length and this is the width, it's going to be 2 of these, right? Length times width is this area. Length times width. So and I need 1, 2. So I need 2 of those. 2 lengths times width plus I need 2 of these faces now. Okay, so we could say width times height. I need 2 width times heights. And then I need 2, what's left? Height times length, right? I need this face. Height times length. Does that make sense? Even if, I'm not asking you to memorize this, but you have to be able to, if you're not going to memorize it, you have to be able to like reason it out. It's all of these areas added up. And why is it 2?
Because there's 2 sides.
Yeah, because they're 2 sides that's identical. You could do it like this plus this plus this plus this plus this plus this without the 2, right? You're just adding them all up. Just the 2 makes it quicker, right? We just know there's 2 of each side. Okay, so there's our sides, there's our formula. Now we can say this is going to be equal to 2, and then I'm just subbing in these values of x, whatever the length or the width is, right? So I'm going to do 2, and we're going to go put this in a big square bracket. X plus 4, and I don't even know which one I'm doing here, but I'm just going to make sure I get all 3 combinations. Okay, let's do this. Okay, so I've multiplied all 3 combos now. This times this, so this face times 2, this x width times this length, so we're talking about the bottom face or the top face times 2, and then x this times this with the side faces times 2. Any questions? All right, now we just got to do the math. The math is the easy part in these word problems, right? It's what to do that's the hard part. So here we go. We get x squared. 5x and 4x gives me 9x. 4 times 5 is plus 20. Okay, plus this x this is easy. Right there, this is easy. Okay, now we have 2. We're going to gather our like terms, so x squared, x squared, x squared. Looks like 3x squared. Okay, and then we got 9x. 4x is 13, plus 5 is 18x. And now we have 20. And you can sort of cross these out as you're going if you want to make sure you don't miss anything. Finally, the last step is distributing the 2 to all 3 terms. Okay? Any questions? All right. We're gonna finish. That's 2. Come on. 3. Here we go. Special products. Expand and simplify using FOIL. Okay, I'm going to need some help here. Let's see who was paying attention. Teodi, what do I do with this one? What's the first step to do with this? Yeah, so how do I do that? So yeah, so what should I write? No.
Wait, no, it's x.
Yep.
Then negative
Negative.
9.
Nope. You need a step in the middle there. Jaden, you remember? Yeah. Because it's times itself, right, Teodi? You're just doing this, right? That's what square's asking you to do. 5 squared is 5 times 5. So you're going to rewrite it, okay? Now, I'm going to do all the steps in FOIL. Okay? So let's do x squared minus 3x plus 9 equals x squared minus 6x plus 9. Okay? That's all the steps. But in your head, right? If you did this in your head, x squared to x times x is x squared. Then the second step you do in your head, minus 3x, and the third step, minus 3x, you could go right to here, minus 6x. Who's taking the shortcut? Who's with you? Nobody's doing the short. Nobody. Should I stop doing it then?
What was your shortcut? Oh, sorry, I was writing down.
What was the shortcut? Okay, I'm gonna show you the
I was
shortcut.
writing down the other answer for B.
All right. Listen. Pay attention. I've been doing it for a while now. We're gonna do it again. Okay? Here's the shortcut. 2 times 2 is 4x squared. Now we know the next two terms we always have to combine, right? It's annoying because I gotta write out them out and then I gotta combine them. So the next one I'm gonna do 2x times 5x. So in my head, what's that? 2x times 5x, that's 10x. I'm gonna carry that 10x. Okay. And now I'm gonna do the next one. 5x times 2x, that's also 10x. So what do? I add them in my head. Plus 20x, and then the last term plus 25, and I'm done.
Oh, see here, I split 10x plus 10x.
Yeah, I know. That's the mid step that I'm skipping. That's the shortcut. I don't know. To me, that's almost simpler, right? 'Cause it's just one number. You're just holding it in your head for a second there. Okay, we'll try it one more time. 3x minus 7. 3x minus 7. Okay. First one, you can write out 9x squared. Next one, you know you're going to combine, so you go 3x and 7. So that's negative 21x. And you get another negative 21x. So that's negative 42x plus 49. Who's with me? Yes, Josiah. Yes. Let's go. All right. Consider each simplified expansion from example 1. We're thinking about each one of these. How is the first term in each trinomial related to the first term in each binomial? Ooh, we're going to develop a formula here, boys. I see it coming. How is the first term related to the, how is the first term in each trinomial